looks like we're good here. So we have the opcode. We need the opcode in the func3. Okay. So go to 0, 0, 1, 0, 0. Let's check what that is. We have to do binary text, which was 0, 0, 1, 0, 0. That will be 13 in hex. So x 13, and then it also matters for func3, and our func3 was it should just be 0, 0x0. Yeah. In that case, we would return add-i, because that is an add-i instruction. Yeah, 0, 0, 1, 0, 0, 1, 1. And then func3 0, 0, 0. Okay. I think that should work for now. And let's just test it out. Let's just test what we have right here. So let's go back to ZP and add it to the test it out. And we want it to be like add-i and then RD and RS1. Okay. So okay, that's true. So what was our thing from before? It was okay. We should set a string first, and set that equal to the function that we had from earlier, the construction. And the opcode will be up here, opcode, and then func3, just like how we had back here. And that should return add-i, okay? Oh, wait, not, why'd I have the left shift operator? This is string. See out. Oh, wait, we need the variable name. What am I doing? We'll say instruction type. Okay, yeah. Or like instruction category. Yeah, we'll just say type because it's type here. Instruction type. Instruction type. So we'll say add-i, and we need the format to be like that. So add-i, RD. So instruction type. Need a space. RD, RS1. It's in that order. So yeah, destination register. So if you take the RD value that we have, space, -1, more space, and then immediate, right? Yeah, immediate. And then we'll have the next line. Okay, that should work. Let's just test it out and see. Test it out using this bit string. Okay. Okay, so it's not exactly working. Let's see what happened. Oh, I forgot to put this here. Okay. Func3, yeah. Func3 equals. Hex 0. Okay, now it should work. String. Oh, should I close it up too fast? And yeah, that actually does. That works. That works. Just like we had here. So yeah, 12. 15, yeah. We do want to get it into registers though. Yeah, we want to make sure it's the register value. So I think I'm going to change this instruction type add I, and then it'll have to be X here and then X here. And then it should be better now. Yeah, so we're adding the register, destination register 13, X13, and then register source 1, X5, and then adding the immediate -12 and loading that into the destination register. That works. Okay. Now we can work with different instruction types. We can see what's going on. We have a lot of instructions to load. That one does work. Let me just see it again one more time. Okay, so we have output 19, 13, and yeah, I think everything's right there. Let's try and load a new instruction now. Let's try doing shift left logical, and that would be okay. That's also an I type. Yeah, let's give it a try. So, maybe I'll put a comment here. I'll put a comment here just to say, or should I should put it over. Just to say that this is the instruction for the instruction. Okay, and we can check what it is for shift left logical. It'll be the same exact opcode. So, but just the func3 changes. So it's gonna be 001, which should just be 1 in hex. Did I check that right? Yeah, 001 for func3, so that should just be hex. But okay, we need a func7 now though. Should just be 0. Because the immediate is split into 2 different places. Okay, that's a bit more complicated. We need to check all. For now, let's just check with. For now, we'll just check with Chinese and see if this is working so far. If this is a good way to do this. he means like it doesn't. Okay. For now, we'll just have this just in case. Yeah. Okay, unknown. That's probably better. Wait. Oh wait, this is the string. We can't do that. Sure. Go by opcode first. Nested if. That would be better if they're all like the same opcode. That makes sense. Yeah. Yeah, no, that would be better. Okay. So first this, and then add this in after. I'll just go with this for now. Add this in after. So if that happens, then you're gonna turn and then we can do the different scenarios for all the opcodes that are that value. So which would fall under all these I types? All these so far don't need fucks, so I'll write out these 5 for now. Okay, so we already got the 0, 0, 0. For now, we need the AND I instruction. We need 1, 1, 1, which is 7 and X. Else if 7, 0, 7, which will be returning AND I. And we have or I. And that should be 6 in hex, I'm pretty sure. Return AND I. Could you run it else if 0x6. Yeah, that's right. 1, 0. And then that's return for I. Now we need exclusive or I for 1, 0, 0. Should be 4. Yeah, 4. Else if 1, 3 is equals. Yeah. Exclusive or I. They all have the same structure, so we won't have to worry about changing the structure. For maybe for these last 3, maybe a bit changed. We have 0, 1, 0, which would be 0x2, which is for shifts less than immediate sign. SLTI. SLTI. That'll be for x2. And then the last one here, SLTIU. 0, 1, 1, which is 3. a semicolon here. Turn. What was that again? SLTIU, unsigned. Okay, should be good. So now this should work for all the cases of I-type until there. I need to implement these three, but these three need a func7. Let's try it on. I'll try. I got this. Yeah. Comes on func7. Wait. Oh, okay. Well, we'll rewrite that part when it gets there, yeah. When it gets to that part. Because if like any func3 is the same. Yeah. What func3s are the same? 001, it's the same as like, well, that doesn't have the same one. 101 is also different. But these two are the same. It doesn't seem to be the same as the others though. 101, this is 45. Yeah, okay, so we'll implement that later when we get there. We already tried add I, let me try and right now. Let's just test out. So we put this, we get and I x2, x13 as we wanted to get. And then where are we going? X7. We'll try explicit lowercase now. Explicit lowercase works. We'll try this one. Shift left. I mean, it seems to work. Most of these cases work. Oh yeah, we should test sign extension just to make sure. That's a good idea, chat. And our immediate would be -1, that is correct. And it looks like the everything's good to code 19. So yeah, all of it looks to be right. Wait, func3. Yeah, it is. Okay. I already know how to do this. I just like it's so much. I don't know how to do that, but I'll skip it for now because I already been practicing with that. Now we need to implement func7. Oh, not Discord. Open up Discord. Alright, func7 now we need to implement. I'll write comments next to each one just to add clarification of what it is. So it should be I. right so far. Okay, so we got basic. We got like the basic R type now. I mean, basic I type, not R type. So now we need to implement these ones with Func 7. So, let's see. Okay, so we need to implement. Not for R type, we're doing for I type. And these three are SLLI, shift left logical. Yeah, 12-bit immediate split. So the bits are slightly different, so I'll try implementing for now. Let's just try. So assigned int. We need to get Func 7 part. We'll just be taking the same value from the bit string. Okay. So if it's func7 for this, it will be these 7 bits from 25 to 31. So we need to shift a good amount. So let me just copy this. Change this to B. Value shifted by 25. No, 24. Wait, no. What am I doing? It's 25. And the amount. So how would it? 7 bits, it would be. The hex number would be 7F. Okay. So 7F. And then we need also need to get the, what is that value again? The shift amount, yeah. And what bits would those be? Those would be 24, 20, so it takes up 5 bits as well. It also takes up 5 bits, so value. It'd be the same as the RD and the R, so it's a 1F. And we can just confirm in the binary hex. Yes. So masking it like that, yes. 1F. Okay, so implemented these 2 functions now. Let's just give it a try. Okay, let's use this example. Let's try it. I feel like I'm gonna get something wrong here. Wait. Oh, we didn't return a value. What am I doing? Return. Return. So how am I going to do this? Wait. it's a bit of a lot of change here. Okay. So yeah, let's just take it one step at a time. Let me just declare these functions first. Full declaration for these functions in the decoder. I think we can move this up further up here instead. Same thing for move this entire function up. Or, no, we can just keep it in the same place, doesn't matter. Okay. So we need to figure out how this actually goes for the rest of the instructions. First, I can for from 3001. Okay. Wait, that's the same one from. Which one was it? Was it the same? Or we didn't have anything that's similar to that, right? No, we didn't. Okay, so we can just establish a new one. There's one. If that's the case, then we can have this happen. These are the same, under the same functory, so we're going to have to establish a new one. So, okay. Zero x5. So this is going to take the fifth one, and it's going to be split into two. Okay, wait. That's kind of crazy, bro. Nesting three times. I guess we can clean up the later if necessary. Okay, so if it's under this, it depends on the opcode. Wait, okay, so the functor is this, and so and the func 7 is going to be equal to, and that's just 0. So function 7, that's 0. We will have that. Okay. Yeah, so that works. And then now, for this case, if the func 3 is hex 5, it can be either one of these two. It depends on the func 7 though. So if the func 7 is equal to, and that is, okay, that's just gonna be 0. And return, what is that? Shift right logic. I mean, equal to, and what would that be? is there for that. We need to actually implement it now. So depends on the instruction type now. On what we actually print. Okay, wait, this is gonna be kind of confusing to implement. Wait. Okay, yeah, I think I have an idea. So do we have three like things? Like okay. Like if the instruction type just move this up here. Instruction type is equal to I got like 3 ORs like this. Like I'm not actually sure. I've never actually done 3. I think we can. So this is the case. Then we do is that and then it's in phone 7. Or we'll say the what did the other one first? What was it again? Shift mount. Okay. Shift mount. And we actually need to declare it up here. Okay, now we can replace the variables. Shift them on here, and then we also need after I put in the else. Or for now, just an else. If we have any more cases, we'll add else if, which we probably will, but we will probably come back to that later anyways. Okay. Let's actually give that a try. We need some example bits. Okay, so if we have that, let's see if it works. Oh, it's not the variable. We forgot the function. Okay, wait, we need to put under these. And we also need to change our header file. I forgot about that. Yeah, what's up, Rex Noctis? How you doing? Okay, is there anything else you need to change? Let's get our bit again. And that did not work. Let's see what went wrong. Still getting the immediate. So why is that? Did the opcode change? No, opcode's still the same. So why is that not working? Wait. I actually have no clue what went wrong. Wait. So returning that, that's right. And then going through this function, the header file's initialized right. Value should be, oh, dude, okay. Yeah, this is the problem with copy and pasting, bro. Sometimes you just forget to change stuff. Hopefully it works now. Let's see. Okay, there we go. Alright. Yeah, that's so dumb, dude. Just one little thing like that can change it. Okay. Okay, so now it works. And get the right instruction. Okay, it looks like it's going pretty well. Let's just check in with chat and see if my logic works or if there's a better way to implement this. Let's just show chat what I got. Alright, let's just show chat and see what he says. Oh yeah, also, I'll show him what I put for this too. Let's see if he thinks it's good or there's a better implementation. Using commas. Oh yeah, we do have commas in the actual thing. How do I remember so much? It's not really like remembering, you just like understand the basic logic, and most of it's coming from this chart. Just, I don't even have like all this memorized. Just understanding like the basic concept and then using charts and whatever you can to get it. And then the rest is just thinking logically about it and just practice. That's pretty much it. I'm still like a beginner in this stuff, so I can't like do the higher level stuff. I'm just testing out myself. So yeah, you can also do it too. Like guaranteed most of also like the senior developers are also like, if they forget syntax, they're just checking out some stuff. So it's the same case with what I'm doing. I'm just checking the charts and just doing what I can with that, understanding logic. Okay, what was I doing again? Okay, yeah. Oh yeah, adding the commas. Yeah. Where do I have it? Oh, yeah, here. And the commas are in between these two. Okay, already worse. Oh my god. Okay. Let's grab this. Okay, looking much better. Now let's see what the next steps are. Oh, did he give any more feedback on this? It's inefficient. Okay. Okay, wait, is he saying? I think I get what he's saying. Okay, wait. So he wants me to initialize it itself within here, maybe? So, like, I want to initialize it every single time instead. I think that's what he's saying. Let's just check with him though. I'll just comment this out for now. I mean, that makes sense. Yeah, so I'll get rid of this now. Let's initialize it in itself. This bug. Alright, we need a predefined weight, so just this one, since this one we need before everything, but these shift them out and we need after, so we still need this before. Okay, yeah. No, but we still need the immediate, so what's up with that? Oh, and then probably just move this before all the other prints. Wait. There's no way to put it because I want this under all of this. But if I move this, then we won't have the instruction type anymore. Wait. So confused, bro. check what he's saying. So if not, I'll probably just initialize it. There's no way to actually like move that properly. Yeah, they only exist here, but that doesn't make any sense to put that like that. Oh, wait. Oh, since there's no new line, it will all come on the same line, and then... Oh, okay, I see what he's saying, okay. So instead of having them hit here, no new line either, we just end it here, and then, where is it? Move these up. Or wait. I don't know why I'm getting confused by this, bro. After. It should still be on the same line as that. This should still be on the same line as that, but we do the next line. So then the rest of it goes down. And in the same case here. I'm just gonna switch it. Okay, I don't know why that took me so long to understand. Let's take this. Yes, that works. And then these values are still down here though. I guess it's fine for now. initially until we have to change. I'm not gonna worry about this too much. I think it's fine. Like as it is. Yeah, I think this is fine. Like it's not really a big deal to have the output different like that. And then I want to try it with the other one. The other. Where's that? I'm just gonna test like 3 of them just to see. So if that eye is correct. Then I'm gonna test. I'll just test exclusive work. Oh, did I even copy right here? Did it just fail? Exclusive or I. That looks right. And now we can try the other type of instruction, the shift instructions. Let's hope it works. And yeah, it does. The immediate's not there, and we have shift them out 3 and then func 7. And then we'll also try out one of these 2 cases, which would be. Let's try this. Shift right, and the func 7 changes. Okay, that's perfect actually. Okay, so now we've actually done all the I type for arithmetic instructions. Every single one of these. Oh yeah, we should do one sign extension one to make sure assign extension works. And it does work. Using negative values does work. Yes. Alright, finally. Okay. We can move to R type instructions. R-type is a bit different. So R-type, we have the opcode changes between different types of instructions. So as I saw here, the I-type was 001, 00011, so we could use the same opcode for all these I instructions. So now since we're moving to a different type, you have to use a different opcode, 0110011. And we also still have to include func7. Probably won't implement all of it right now, but I'll just start for now. Just start something. So for the last one, we needed RS1 func3 destination register and then opcode. This one slightly shifts a bit. So you have the source register 1 func3 already opcoded. Everything's the same, just the amount of bits. We don't have the immediate anymore. So we func7 is 7 bits and then RS2. So the immediate's kind of split between those. RS1 is the same amount of bits. All these are the same. Landing is the same, it's just we implemented one in here, so we need to add that. Okay. Func7 was 7 bits. Yeah, 7 bits. Was it also 7 bits in here earlier? I think so. Let me just check. That is 7 bits, yes. Okay, func7, okay, everything is the same except I need to add RS2. So we need to add a new function. RS2. No, I should the same value. Inside in 32. Also declare that in our header file. Okay, so the shift amount, let's see. So for RS2, here's my 7, so we're shifting shifting 20. So the value shifting 20 bits and then masking it with, it's 5 bits, so it should just be 0x1 if it's 1. Now we need to actually implement it. huge if statement, bro. It's like we have so many instructions like this. Wait, the opcode's 6. No, there's 7 bits, right? Yeah, let's just do it. It's fine if we need to clean it up later. So, the opcode is... And what is the opcode for this? What is that in hex? 33. So opcode is that. And it's the same logic. New parameter now. Wait, do we need a new parameter? No, we don't need a new parameter. What am I doing? It's just checking the opcode. That's literally it. Okay. So if the opcode is that, and the func 7. Hex 0 and wait, let's actually see. Wait, so these func sounds are the same. Okay, wait, no. Because those two are the same functory, so we need to have a separate statement. So if it is 0, then we'd have that's also 0, 0. And we return the type of what it is, which is going to be that. I think this is fine. I just want to check one thing though, a program like this. Like, I don't see any other better way to do side investing. Yeah, it doesn't scale, but it's probably better off to just change that now, so it doesn't like get cluttered with a lot of these instructions later. But yeah, I think for now I'm just gonna end the stream. We'll continue off tomorrow from where we left off, and we'll just continue writing this instruction decoder. So yeah, I'll see you guys later.